Good morning, everyone. I'm Başak Bostanci. I'm an assistant professor from Istanbul, Turkey. We are going to talk about the newer designs in trifocal technology, Acriva Trinova IOL. Obviously, I'm a speaker for VSY. So when we are talking about the traditional IOLs, we must emphasize that these lenses have really sharp edges in the transition zone. So when the light rays hits these transition lights, these sharp edges, some of the light is lost, like approximately between 15 to 20% of the light. So this will cause blurriness in the vision. And one more thing in traditional trifocal IOLs is the low light distribution. Especially under mesopic conditions, how much you see is not satisfactory for reading the menu in a restaurant or trying to read something when you're in the car. And in traditional trifocal IOLs, you will have much more glare and halo. Today, the lens we are talking about has a sinusoidal vision technology. So trifocality is created with a wave-like surface profile in this lens. What means between the transition zones of the diffractive rings, there's a smoother transition. So more light is transmitted to the retina, and there's an optimum light distribution. And you will have less scattered light just because of it. You will have less halo and glare. And one more thing to add is, in this lens, the trifocality is combined with enhanced depth of focus for continuous vision. So once again, when you compare Acriva Trinova's surface profile to traditional trifocal IOLs, you may see that the sinusoidal profile on the lens provides less halo and glare, especially under mesopic conditions. So how much light is transmitted to the retina? Well, studies show that approximately 92% of the light is transmitted. So when you compare it to the other three leading trifocal lenses of the market, you may see there is a 10% difference. And in a healthy individual at the age of 30, the light that is transmitted to the retina is approximately 95%. So when you compare 92 to 95, you may see that this light transmission is really good. So we learn a lot from the defocus curves of multifocal lenses. So the defocus curve for a presbyopia correcting IOL plot visual acuity over a range of near defocus. So because visual acuity is directly related to the light energy, it is possible to predict the size, the shape, and brightness of photopsia from the shape of a defocus curve of a lens. What means is a bifocal IOL has peaks at far and at near, and a dip in the intermediate. So decreased light energy in the dip here creates a separation between the point source of light and the object. So the amount of at power determines the size of the halo. So if you increase the at power, you will have a bigger halo. And the height of the peak correlates with the brightness of the halo. So when you make a closer near point with greater light, it will cause a bigger and brighter halo. So we have to keep this in mind. So one more important thing about multifocal IOLs is the modulation transfer function. So we all know that the ability of an optical system to transfer contrast from an object to image is MTF. So if you have a higher MTF, you will have a higher image contrast, and it's directly proportional to your visual quality. So as you see, when you compare the MTF graphic of this lens to the leading other three trifocal lenses in the market, in every point for the infinity, for intermediate distances, for near distances, the MTF of this lens is higher. What about reading? So this lens profile provides a +3 diopter for near vision and +1.15 diopter for intermediate. So you can have up to 42 centimeters of depth of focus, and you will have up to 80 centimeters reading distance, which is good, which is very satisfactory. So again, light distribution is very important, as I said, for a seamless continuous vision. So when you look at the conventional trifocal lenses, they will all provide a good far vision. But what about mesopic conditions? So when your pupil is larger, your near vision and intermediate vision is inadequate. So remember this, in the cataract age group, how you read in a restaurant, how you drive and use the panel is very important for your daily life. So this more continuous light distribution is thanks to the sinusoidal surface of this lens. So this graphic is showing the light distribution in photopic and mesopic conditions. And as you may see, these lines are very close to each other. Like when you compare them to the other three lenses on the market, you may see a gap between the far and near and intermediate. And when you look at it in more detail, you will see that Acriva Trinova's numbers are very close to each other when you compare the photopic conditions with the mesopic ones. So one more important thing for me is the tolerance to decentration and angle kappa. So anyone who is placing a multifocal IOL must know that the patient must have an angle kappa that is less than half of the central optical zone in order to make the person happy afterwards. So if the lens is decentered because of failure to accommodate for angle kappa, the central rays, light rays, will miss the central optical zone and they will pass through one of the multifocal rings instead. And this will create halo and glare in the patient. So this is one of my patients. As you may see, the lens is slightly decentered, like 1 millimeter decentered to the nasal edge. This patient is very happy and she has like more than 0.8 visual acuity for far, and she doesn't want to be operated. And this is thanks to this large optical zone, central zone. So IOLs with a wide central ring may tolerate larger angle kappa. So again, a comparison with the lenses on the market. This lens has a 1.4 millimeter central ring diameter. So when you compare it with the others, you can understand easily that the tolerance to angle kappa is higher. But, I'm not trying to emphasize that you can put the lens wherever you want to. Perfect centration is still the key solution, like this. So another two things to add is the mild negative asphericity correction, because we don't want to correct the whole spherical aberration of a patient if you want a patient to be happy. So this mild negative asphericity is really optimum, because studies show that we have to have at least some amount of spherical aberration in a multifocal patients afterwards. And the chromatic aberration control is really important, and it has the highest AB number in the market. And what about eyes with astigmatism? Are we not correcting these? No. We all know that over 0.75 diopters of cylinder, we try to correct the astigmatism. What I really like about this lens is the ability to align the lens in both directions, because when you're trying to do the whole tour in the eye of a patient, it's really, because I gave my own father, a toric lens, and when you're trying to dial the lens, it is really not easy. So the possibility of the alignment in both directions is really one good property of this lens, and it provides a good range of diopters. You can correct up to 10 diopters of cylinder, and the lens goes through less than 2 millimeters incisions, which is good for your spherical, surgically induced astigmatism. So in this photo, we see how nicely aligned this lens in the post-op period, and the stars show the properties for having less glare and halo afterwards. So studies show that if you have zero angulation in the lens, this will decrease the amount of glare and halo in the post-op period. And the blue balance technology with the natural chromophores inside really provides a good vision. And I told about the optimum light distribution of this lens. So what about our study? So we implanted 30 of these IOLs in 15 patients, and I followed them up to 6 months actually, but the results here are for the first 3 months. The exclusion criteria is standard. So I am going to talk about my outcome measures in a while. So my study population is really a normal standard cataract surgery population. I did the pre-ops with an Alatin optical biometer. I used an Haig's formula. And I checked the binocular and monocular uncorrected distance visual acuity. intermediate for 80 centimeters, near for 40 centimeters, and we did a binocular defocus curve. So this is in decimal how the uncorrected vision changes. So as you may see by the end of 3 months, there were people who were seeing better than 20/20, which is good. And when you check the intermediate vision, 90% of our population were seeing at least Jagger 2. And for near vision, more than 90% were able to see Jagger 2 and 1. And how about bilateral intermediate vision? Like nearly 95% of the population were at least Jagger 2. And for near vision, all of our patients were reading at least Jagger 2. So this is the defocus curve. As you may see, there's no big, huge gap here. So it's good. You may, predict that the amount of halo and glare that the patients will have is less compared to other lenses. And the contrast sensitivity reports in the first month and 3 months are between the normal range. So when you before questioning the patients, no one actively complains of any light disturbance. But if you question them, if they have any halo or glare in the post-op period, one of my patients said she had halos around candles and night lights, and 2 other patients had glare around the headlights, which is, expected from a trifocal lens. So as a conclusion, I had satisfactory results for me and my patients. And I really like the light transmission, the ABBA number, the MTF, spherical aberration control, and depth of focus of this lens. And one more good thing about this lens is the great toleration of minor off-target refraction and minimal decentration. And for excellent near and intermediate vision, I will keep using this lens as well. Thank you for listening to me. If you have any questions, I'm glad to answer them.